brief recap. In the last session we did was we started doing functions. So before I begin with that, let me just remind you people what all we had done. Right. Okay. Just one sec. All right. So let me just write on the screen a little bit. So functions, I had said that I like to divide the functions into three types: 1, 2, and 3. 1, 2, and 3. So the first is what I call the built-in functions. The second was what is called the imported functions. Imported functions, the functions which you can import from modules. And the third one was what the user writes himself, or the programmer user writes. So I repeat, these are the three types. First is the built-in functions, then is the imported functions, and then is the user defined or user written functions. So these were the three types of functions which we covered in the last class. All right. So today I would like to move a bit ahead. So before I move ahead, I want to talk about one very important concept, which is called scope. And one sec, I'm just coming. Yeah. All right. So let me again do a little bit of more recap. I'll come to page number 76 of my book. For those who have my book, they can come straight to page number 76. Yeah. So I'll just like to talk about how you write a function. Actually, I'm getting a phone call. If you don't mind, I'll just hold. Sushil ji, aap aa rahe hain? Aaiye. Beach mein for 5 minutes, I have a guest. I'll be just meeting that guest for 5 minutes. So I'll excuse myself, but otherwise I'll go on. So we are talking about how to write a function. That means we have already spoken about the inbuilt functions. We have spoken about the functions in the module. We spoke about how to import the modules. I don't think we need to go over that again, but in case you people have not got it properly, at the end of this class, I would like to repeat that. So right now we are talking about how to write a function. So when you want to write a function, you have to do 1, 2, 3, 4, 5, and 6 things. So let me just clear this out and let me again do it. So first is you have to use the keyword def. So whenever you use the keyword def in your code, the compiler or the interpreter of Python will understand that you are trying to write a function. Then the second thing is some function name. You use def followed by function name. Function name. Now this function name can be anything. Now we will talk about the naming conventions in Python later on, but some function name. But this function name should be, it should make sense, because the logic of Python is that code is more often read than written. This is very important. Code is more often read than written. What does this mean? This means that suppose you're writing a Python library, right? So you're one person who writes it, and suppose 1,000 people are using it. So your code will be read by 1,000 different people. So you are one person writing, but 1,000 people reading. So therefore, the reading of the code should be very, very readable. And to make the code readable, certain conventions and norms are followed in writing. So it is very important that you have the good practices of how to write good code and follow the practices. I will talk about that in a later class. But coming back, so first is def, second is a function name. The third is a bracket, and I've written optional list of parameters. Optional. So this means that this bracket can contain parameters or it may not contain parameters. Can contain parameters, may not contain parameters. This is the third thing. The fourth is what I call a doc string. The doc string is included in double quotes, 1, 2, 3 on one side and 1, 2, 3 on the other side. So there are triple quotes. Forget about doc string for the moment. Then there are statement with bracket S. That means there can be one statement, there can be more than one statement. And finally, optional return. So wherever I have used the word optional, that means that you may or may not do it. You may add a return statement, you may not add a return statement. And as we discussed in the last class, if you do not add a return statement, then the Python interpreter on its own will return a none, N-O-N-E, none, right? So this is what the function definition was. I think we can move ahead. Okay. And the next thing I want to talk about is flow of execution of a function. So, a function definition and a function call. So these are two very, very important concepts in any programming language. A function definition, and a function call. So when you define a function, you are simply creating a process. You are creating a process, but when you call the function, then the function is actually executed. And there is another important thing, that the function definition must come before the function call. I'll just explain. The function definition must always come before the function call. Why? Because when the function call is called, then the interpreter should know what that call means. Therefore, it should have the definition of that function before the function is actually called, right? A function definition is that piece of code which creates the function, whereas the function call is that piece of code which uses the function. Let me just do this again. A function definition is that piece of code which creates the function, whereas a function call is that piece of code which uses that function. A function definition, a function must be defined before it can be used. Otherwise, Python will not be able to understand the name of the function. This means that the def statement which defines the function must come before the call. The following code explains this concept. Let us see this. This is the code from my book. This is on this thing, but we will do it. Let me just do it on the this thing. Let me create a. Let me define a function def. Let's call it f, or let's call it my function, my func. Let's call it my func, followed by this thing. Sorry. And inside the function, I do something. Let's say print, say hello world. D, right. Now this is the function definition. The function. Now let me just do this. Now this entire thing is the function definition. It consists of the definition keyword, followed by the name of the function, followed by two brackets. I have not given any parameters, followed by a colon, and followed by a statement, and there is no return. There is no return, right? So this is a function. Now let me call this function. Let me say my func. Now let me run this. So what happened? So this my func, this is the call to this function. And so you see, you must understand that the Python interpreter runs over this piece of code sequentially. That means it first looks into this statement number 1, then it looks at this statement number 2, and then it looks at this statement number 3. But note one thing, that the print statement in line number 2 is not executed until the function is called. So therefore, this suppose I comment out this my function. Suppose I create I you understand the concept of, let me just run it again. So I get nothing. So when I comment out with using a hash, I've used a hash in front of my function. So what has happened is that now this statement will not be executed. So that is the thing. This is the difference between a function definition and a function call. So when I call this function by my func, then so when I run this code in a compiler or in my Jupyter notebook, the first line of the first line of code which is executed is this. So this is executed first. This takes the interpreter to this line, which takes it to this line, and then this line is printed, right? So this is how the thing works, right? So I hope you understand this. I can prove it. So this is the way it works. I hope this is clear. And let me just. All right. So let us move ahead. Okay. No, we were going over my book. So let us talk about this flow of execution. So what is flow of execution? The order or sequence in which statements in a script are executed is called the flow of execution. The execution begins with the first line of the statement. Statements are executed one after another from top to bottom. However, function definitions do not affect the flow of execution. So this means that a script is progressing from top to bottom. If it encounters a function definition, it will be ignored. Therefore, what it means is that if I have one line of code here, suppose 1, 2, 3, 4. Suppose I have these 5 lines of code, and suppose the first, second, and the third. Suppose these 3 contain a function definition, then these 3 lines of code will not be executed. The execution will start from line number 4, and then 5, and then 6, and so on. And suppose 6 calls the function, and suppose after 6 there is 7. So from 6, then 1 will be executed, then 2 will be executed, then 3 will be executed, and then the execution will come back to 7. So what I am trying to tell you is that if there are a number of lines of code, and if a function definition exists in between those lines of code, so while the code is running from top to bottom, the definition of the function will not be executed until the function is called. This is called the flow of execution. It will jump to the function definition, then come back to the point from where the function was called. Note that you can define one function inside another function, also called nested functions. We will not discuss nested functions because that is not a very important concept. It's a slightly complicated concept. So function calls are like detours in the flow of execution. Detour means, in English, the word detour means bypassing something. So that means if you're going on a path and you encounter some obstacle and you go around it, and then this is called a detour. This is called a detour, D-E-T-O-U-R, detour. So this is exactly how Python also works. All programming work like this. Suppose you have 1, 2, 3, 4, 5, 6, 7 lines of code, and suppose statement number 2, 3, 4 contain the definition of a function, then 1 will be executed and 5 will be executed. And if in the 6, suppose this function is called, then 6 will be executed. 6 will take it back to 2, 3, 4, and then the flow will come back to 7. This is very, very important. So this is for understanding. So this is this thing, right? So let me just run this. Let me just copy and paste this small piece of code to make you understand. This is a copy, and let me take it to a. So let me insert a cell above this. So this doesn't 1, 2, 3, 4, and this is actually the commas and my book and the are slightly different. Okay. So this is a, let us run this. There's an error, always string literal. There is, this is the mistake here. Yeah, now it's okay. Okay. So let me just explain this line of code to you. So what is there? Let's call this line number 1. Let's call this line number 2. Let's call this line number 3. Let's call this line number 4. And let's call this line number 5, right? So line number 1 and 2, they contain the definition of a function. So the execution of this code will start from line number 3. So this is print, let us call F1, and this is what comes here, let us call F1. Then we call F1. So once we call this at line number 4, we call F1, so it goes back to this line, and then this is printed inside F1, this thing. So that is why this is printed over here. And once this is then print terminate, then that is why this terminate is printed over here. So if you see this again, you can see that this line is coming here, and then this line is coming here, and then finally this line is coming here. This is because of the concept of flow of the execution. The function definition is never executed, and it is only executed when the function is called. I hope that makes sense to all of you. So let me stop here for a second and just take a feedback from somebody. Am I audible? Am I understandable? Is the screen clear? Is there any problem? Am I going too fast?
Sir. Yeah. Hello, sir. I have a query. I have a question.
Yeah.
So you said while defining the function, if we don't write return statement, yes, Python will print none.
No, it will return none, not print none. I'll show you. Okay, I answer your question with an example. now suppose I write here. Let us say Z is equal to this thing, F1. So what will Z contain now? What should Z? Can someone tell me what will be Z? Let's see. It's a null.
Okay.
The return value of the function, if I don't write this Z, if I don't write this, then the return value is lost. Then the return value, you cannot access the return value because you have not given the return value to a variable. If you want to use the return value, then you have to do something like this, Z equal to F1. So now what has happened is that the return value of this function has gone to the variable Z, and when I print Z, then it will print a null. But suppose I write here, return, suppose I write hi. Now let me see what will happen. So now what has happened? Now the Z contains, let me just this thing. So I have returned a hi, and I have given that hi, the return value, to the variable Z. That is why when I print Z, I get a hi. Is that clear? I hope that makes that explains what your question. I hope I've answered your question, right?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Okay. Okay. There's another very important concept that is very, very important called scope, namespace, and lifetime of variables. Let us just go over this. I think, if you really want to follow
Sir, I have a query.
Yeah.
Sir, if the function has more than 3 lines of code, so how the function determines?
If the function has more than 3 lines of code, it can have any number of lines of code. There's no limit on it.
So how to identify that the function, the written function is
ended?
Yeah.
Okay, yeah, that is because of the indentation. Maybe I forgot to tell you that. See, in Python, this indentation of 4 spaces, this 1, 2, 3, 4. I'm having a guest for 10 minutes, so I'll have to switch off. Do you mind, people? Maybe you can have a discussion on your own, and I can join you.
Yeah, carry on, sir.
Yeah, sure. Carry on, please.
I'm sorry, I have to go for 10 minutes.
Team, please. Hello. Team. We have break for 5 minutes. Don't log out. Be there. Okay.
Thank you.
Sorry, people, I'm back. So am I audible and visible? Just once again, please.
Yes,
Yes,
sir.
sir. You
Okay,
have,
so let us start. So I think this concept of the flow of function is quite. Now we are talking about the concept of lifetime of a variable. It's a very, very important concept. The concept of lifetime of a variable. Right. So if you remember in the beginning, I had mentioned one concept to you that Python has what is called a garbage collector. Garbage collector. So basically, I'll tell you what it means. Even Java has a garbage collector. But I think C++ or at least C does not have what is called a garbage collector. So garbage collector is basically a concept that the compiler will take care of the memory. That means that if you are not using a piece of memory, then that piece of memory will be destroyed. And therefore, for the garbage collector to step in, there has to be what is called the lifetime of a variable. This will become very clear to you. We'll do an example of this, and we'll talk about what is scope, local scope versus global scope. So let us understand this by example. The best way to learn programming is to do something, right? Okay. So okay, let us run this piece of code. Oh, right. let me just comment out this line. Now let me run it. So wait. No, this X is being, let me just change the name of the variable to something else. Let me make it C. Dog. Why is it? Okay, let me print here C. No. Oh, wait. Okay. No, this is just a simple example. Now let me just explain it to you. I have defined a function f1 and I've given it a variable a. Now, there is a very important concept of parameter versus arguments. Listen carefully, parameters versus arguments. So what is contained in the function definition? This a, this is a parameter. And this c, which you are using to call the function, is the argument. So what is happening when you're calling the function? This c goes into the a, right? And the c happens to be a cat. Inside the function, now let me just do this. Let me just so inside this function, this c here will be your cat, and the a will be also a cat, because the c has gone into the a, and the a will be equal to cat, which is the cat over here. So you get a cat and a cat. You get a cat and a cat. Now there is another variable called d, which is equal to dog. There's another, let me just draw this again. There's another variable called d. Another variable called d, which is equal to dog. Now this d exists inside this function definition. This d exists inside the function definition. It does not exist outside this function definition. Therefore, if I try to call print d over here, let me run this. I get an error. Why do I get an error? Let me just show this. I get the error, name d is not defined. This D over here is not defined because this D is existing in the scope of the function F1. So what is happening when the compiler runs this program? It allocates certain amount of memory to a variable D. But the moment this function call is over and the flow comes back to the main script, then this D is destroyed. That is why the print D will not work over here and the D will not be understood by the script. However, the C, which is a cat, is understood here. So this is called the global. Let me just draw it again. So this is the local scope and this is the global scope. Let me write it again. This is the global scope and this is the local scope. So you can think of it wherever there's an indentation, this indentation of 4 white spaces. Did I mention that to you? Because in function in Python, the way you create scopes is by indentations. Like in Java and C++, you use curly brackets, but in Python you use indentations. So wherever you have an indentation like this, you are creating a local scope, and there is a global scope and a local scope. So this is the way it works. Has everybody understood? Let me stop this for a minute and say, has everybody understood? Somebody would like to answer the concept of local scope versus the global scope? Anyone? Someone?
Yes, sir. We got it.
Okay. Now let me just show you. Let me just show you how there can be a variation. Suppose I write here C is equal to. Suppose I write car.
Can you give another example for this?
Yeah, okay. I will just let me finish with this, then I'll give another example. Let me run this. So what I have done, I have defined a new variable C inside the local scope. Inside the local scope, I have redefined C as equal to car. Right? So therefore, inside, if you have, now what is happening? The same variable C is having 2 different definitions. Inside the function, it is defined as car, but in the global scope, it is defined as cat. So in the local scope, that means inside the function, the local variable will overshadow the global variable. That is why you are getting a car over here from this C and not a cat. But suppose we do something else. Now suppose I write print C here. Let me to make it clear. Let me write global scope. Let me run this now. So let me just show you. So we have 2 C's here. One C is here, which is being printed here, and the other C is here, which is printed. Oh, so I'm so sorry. I'm so sorry. No, it's fine. No, I have to remove this. D is no, I have to remove this line. Now let me run it. Yeah. The error was there because I was printing a D and the D does not exist outside. That is why. So I've commented it out. Now there will be no error. So now you need to see that there is a C over here and a C over here. So you can have the same variable in the local scope and the global scope. So what is happening? In the local scope, the local variable is overshadowing the global variable, right? And in the global scope, the local variable does not exist. In the global scope, the local variable does not exist. and only the global variable exists. That is why when you write this C over here, you get a cat and not a car. Is that clear? Let me just, because this concept of scope is very, very important. So you need to, we'll take some more examples, but have you understood this, right? Someone would like to answer? The lady who was asking?
Yes, sir. Yes, sir.
Okay, fine. So we can move ahead, right? Okay. So let me see if I've written some more examples. Let me run this program. So I've written this small script, local versus global scope for some variables. X is equal to cat over here. Now see, this is, no, let me just write this again. So from here to here, this is global scope. From here to here, this is also global scope. And from here to here, this is local scope. So you have a global scope, followed by local scope, followed by global scope. I hope that is clear. So what is happening? X is equal to cat in the global scope, and X is equal to dog in the local scope. Print X inside the function call is X. So X inside the function call is dog. So we are getting the variable X over here. And when we get out of the function, when we come again into the global scope, X in the global scope is X, which is cat. Is that clear? So if you don't understand the concept of scope in Python or in any other programming language, you will not really be able to write good programs. So it is very important that you need to understand that variables exist. You can, the beauty of a language like Python is that you can define a variable anywhere in the code, right? But that variable, whether it will exist, where it will exist, if you define it outside any of the function definitions, if you define it any outside any of the class definitions, we have not covered classes, but if you define it in the then it becomes a global scope. It will always exist. However, if you define it inside a class definition or inside a function definition, then that variable will exist only within that function definition. Of course, there are ways to change this behavior, but this is the normal behavior. We will cover those examples also later on. Now, let me show you another example. This is a function where there is a global scope, then there is a local scope, and there's another local scope, and then there is a global scope. So if I draw it like this, you can think of this as a global scope, then local scope of F1 and local scope of F2. So if you are writing here, if you try to find the value of X here, you will get X equal to cat. If you are doing it here, if you're using this print statement, you will get the value of dog. But if you're using here, you will get the value of rat. That is why X in F1, so here I've written X in F1, X in F1, here it is dog, that means this dog is here, this line. X in F2, this is rat, and X in global scope, this is cat. So I hope this is clear. Let me just again show this to you. So this statement here, this creates dog from this dog. This statement here, it creates the rat from this rat over here. And this statement from here creates the cat from this cat. So this X will be visible here. So because this X is in the global scope and these three statements are also in the global scope. So if you print the value of X over here or over here, if you suppose I was to write print, let's say X of global scope, then I will get So you can see that. Now let me see. So this X and this X, they are both in the global scope. This X is creating this line of print, and this X is creating this line of print. So if this is clear, if the concept of scope is a little bit clear, then we can move ahead. Tell me, has everybody understood? Anybody can ask me a question on scope because this is very important concept. Yeah. Everyone clear?
Yes, sir.
Yes,
All right.
sir,
So
clear.
let us move ahead from scope. We have covered scope. Right. Okay. Concept of
Sir,
lifetime.
I have a
concept of-
question, sir.
Yes, please. Please ask. Tell
Sir,
me.
question, please.
Yeah.
Sir, why do we use local and global variables in Python?
Yeah. The reason is that otherwise there will be something called name clash. There will be something called name clash, number one. And the other reason is that, you see, the moment this X equal to dog exists only within this F1, the moment we go to F1, this memory gets freed. You see, whenever I write X equal to dog or whatever, what is happening? Python is reserving a piece of memory, this memory, and contains the binary equivalent of the dog, and this memory has the address of X. So if I don't destroy these pieces of memories, so every time if I call this function 1,000 times, then 1,000 such pieces of memory will be used up by the compiler and the interpreter, and ultimately you will run out of memory. So this is what the Python interpreter, garbage collector of the Python interpreter will. We can go into the minutest of details of garbage collector if we have enough. But I understand that your focus is not learning Python so much as to go on, more into maybe hacking and those, and that's what I was told by Balaji. So, but if you want, we can go into the minutest details. The point is that if this
I
function
have
is
also
called,
question, sir.
yeah.
Sir, I have a question that just like in C, also Python has macros like concept or not?
Macros.
Yes, sir. Just like
Yeah,
in
so the equivalent of a macro in Python, to my, because I am not very good in C, but the module of Python modules and libraries are equal to the macros of. I think this is correct, but let me check this up, and let me get back to you on the next class. All right. So
okay.
that is the all right. So shall we move ahead? Okay, I think concept of scope is a bit clear.
Can move ahead.
Yeah, we can move a bit fast. We can do. Can we go to the next chapter if everything is okay so far?
Sir,
Shall
I
we
have
go-
a question.
Yes, please.
So can you explain that dog and cat one again?
Okay. Yes, please. Again,
Not this one, so the previous one.
previous one.
Previous to this.
This one.
No, sir, the previous one. Previous to this one, sir.
Previous to this one. This one.
Yeah, yes, sir. This
Okay. Okay. So I think you are confused between the variable C has got two definitions. The variable C is defined in two different places. They can coexist. There's no problem. So inside the function F1, C will be a car, but outside the function F1, C will be a cat. Inside the function, the variable C, the local variable C will dominate or shadow the global variable C. That is the way Python is designed. That is the way most programming languages are designed, that inside the local scope, the local variable will dominate, but in the global scope, the global variable will dominate because the local variable doesn't even exist. So this car does not exist outside this definition of F1. So now I am having two print statements. One is here, and other is here. In both the statements, I am printing a C. I am printing a C here also. I am printing a C here also. The thing is that inside the definition, when I call this F1, inside the definition, the C is a The C is a car. The C is a car. But in the global scope, the C is a cat. Is that clear? Or should I repeat
What
it?
about A?
Forget A is just a confusion. Let me remove A. A is simply you are getting confused by A, right?
Yes, sir.
So let me just remove this A. But if I remove this A, then I cannot use this A over here also. So can we run like this? No, wait. Some mistake is there. No, we cannot call. Yeah, so I have to call without the C. Let me run this. Let me see. That A was a distraction, not required. So I've removed the A. So now
Yes.
again, now we are having two C's. One is here, which is printed here, and other is here, which is printed here, right? So inside, when I'm now F1, since this is being called before this print, since this F1 is called before the print, therefore this C will be printed before this C, right? Now suppose I was to reverse them. Suppose I remove this line of code. Let me remove it. And let me put it above this. Let me put it here. So what I'm doing. So now what will happen? Earlier you see, earlier this C was getting printed after this C, right? After this C. But now I have put the global scope above the F1 call. Let me just run this now. And you will find that this, now let me run it. See, now just see. So what has happened is that this line of code is printed first. And then F1 is called, which takes the thing here, then it comes to here, then it comes to here, then it comes to here, and there this C is printed, which is printed here. Is that clear?
Yes, sir. It's clear.
Okay. Yeah. So I think we can. So we'll move on to chapter 5 now. So maybe I'm going a bit fast, but it's programming is always about learning by doing. So you should try to do all these things on your own, and ultimately that is how you should be able to use it. So in the chapter 5, these are the learning objectives. So we're talking about passing the variable to the function in two different ways. Passing by value versus passing by reference. This is the first concept we will talk about. Passing by value and passing by reference. Then we will talk about the concept of function arguments, default arguments, positional arguments, and keyword arguments. So three concepts: default arguments, positional arguments, and keyword arguments. This is the next thing. Then explain how the Python interpreter searches for module. This is concept number 6. This is not so important. Then differentiate between recursion and iteration. Recursion versus iteration. This is, you can say, 7 and 8. Then using variable number of arguments in a function or a definition call. This is concept number 9. Then the list, this basically ends the major part of the chapter. Then list the use of zip, lambda, map, and filter function. These are not very important. Outline the concept of a generator. These are slightly higher concepts, and the use of yield statement, implementing the next function or the next method. So these are the concepts. Let me repeat them again. The important concepts are these ones. And these ones are not so important. But we'll try to cover as many as we can. So passing by value, passing by reference. Then concept of function arguments, default arguments, positional arguments, keyword arguments. Let me repeat. default arguments, positional arguments, and keyword arguments. These are very, very important concepts in Python. And if you understand these concepts, you can straight away start using Python libraries by word go. After, if I cover this chapter a little bit more, I cover on classes, you should be able to use the libraries and start making beautiful diagrams and whatever you want to do. Differentiate between recursion and iteration. This is a slightly complicated concept. It's really not required for those who are not into hardcore programming, right? Just one second. Uma! Just one second. So, okay. Then variable number of arguments in a function call. These are the, let's go over these. Let us start. Let's not waste time. Let's go straight to the thing. Call by value versus call by reference. It's the first important concept in calling of a function. When you call a function, then you can either call, then the call can either be by value or it can be by reference. Call by value versus call by reference. So let me just do this again. Call by value. Here, a copy of the variable is given to the function. I'll just explain. Function call. So any modification to this value will not affect the original value. Call by reference. Here, both the original variable and the variable name inside the function call point to the same object. Hence, any modification to the object pointed to by the variable will reflect even outside the function call. So one could say that a reference to the original object is passed to that address of the object. I'll explain. In Python, both call by value and call by reference is possible. And it will depend upon the type of the object which is being passed as a function called to the parameter. Let us just By the way, I have on my GitHub page you will find the HTMLs of all the chapters. I'll just show it to you. This is my GitHub page, and if you, in fact, anyone who wants to be a good programmer should be able to use GitHub, and so all of you should put in some effort to learn. So this, if you go on my GitHub page, and I think I told you that this is my. If you type AG999 Git on Google, you should be able to come to my GitHub page. Let me just show you. I think it. Let me just try. If I type GitHub AG999 Git, so I'm coming to Anurag Gupta. So just let me just show you. I did a Google on GitHub AG999 Git AG999 Git. This is my GitHub ID. So I am coming to this. This is my page. So for those who are not very familiar with GitHub, just do a Google on GitHub space AG999 Git. You should be able to read on my page. And when I click it, I reach this GitHub page. Now you just need to understand a little bit of. So these are just let me. So there are a number of repositories on my page. There's a repository called Jupyter Notebooks. Forget about it. There's a repository called Articles and Talks. Certain articles are written. Forget about it for this course. Otherwise, you might find something interesting. There's a repository on data. This is the repository I'm interested in. It's a public repository. That means anybody can access it, but only I can modify it. So let me just. So once you reach this page, once you reach this URL, then you click on this book Python Programming Problem Solving Packages and Libraries. Now let me just show you again. So there are now this blue thing. This represents a folder, and this white thing represents a file, right? So there are 3 folders: online chapters 21 to 25. My book has 25 chapters. 20 are in the print book, and 21 to 25 are free online available in print form. I can show you. You can just go over there and you can see it, right? You can see this. This is chapter number 21. Right. In case it does not display, which it should. See, this is matplotlib. This is my chapter number 21. Matplotlib is a very important library of graphing library of Python. So a very beautiful chapter has been written on, and this is totally free. You can just go online and see this, right? So let me go back to this online chapter. See this side, left side, this folder is there. But the one of concern right now is book chapters in HTML. So these are in HTML, but if you go down, then these chapters also have a link. So right now we are going into chapter number 5, which is this is the chapter. On my book, if you see chapter number 5. By the way, I'm not telling you all this because I'm trying to sell a book or something. I have a good job and I'm not looking for any money. I have not made any money out of this book. So this is basically more out of this is chapter number 5. So these are the learning objectives of my book. As you can see, these are the learning objectives. Microsoft, they like to use these words. Microsoft, I said, sorry, McGraw-Hill, LO1, LO2, LO3. These are learning objectives. LO1 was passing the function in 2 different ways: passed by value, passed by reference. Then concept of function arguments, default arguments, positional arguments, and keyword arguments. Explain how Python interpreter searches for modules. Differentiate between recursion and iteration. Use variable number of arguments in a function definition. These 1 to 5 are the important concepts. Then 6 is use of zip generators, and these 6, 7, 8 are not so important. They are slightly more advanced concepts. So today we'll try to cover, let us see how many of these 1 to 5 we can cover. So let us move ahead with the book. Okay, so let me just come to this thing. Okay. Let me run this program. Let me run this script. I have copied this. I've copied it, and let me run it. And let me insert a cell below, cell above. Let me go to the top. So okay, this is a bit advanced, but since I have not covered the concept of flow control, so let me tell you that there are 2 statements, if and elif. These are covered in the next chapter called flow control. But what is happening is that if the statement is true, then this will be executed. And if the statement is not true, else if, then this will be executed. So basically, this function contains two blocks, if and elif. So let me just run this piece of code. Basically, no, first let me explain what I'm trying to do here. Let me just explain. Basically, I have defined a function fz, and this entire thing is the function. It contains 2 blocks, if block and a elif block. This much is clear. Now I am calling this function twice, once over here and once over here. In the first call, I am using a integer. In the second call, I am using a list. So this is basically what I'm doing. So when I call with a equal to 5, then if type z is int. So in the first call, only this part of the code will be executed. This has become a bit, let me write it again. So this is call number 1. This is call number 2. in the first call, since a is an integer, therefore this part of the code will be executed. In the second thing, since z is a list, then this part of the code will be executed. This is what the thing. So I have written a function. This is my function. It is called f. It contains of two blocks, an if block and an elif block. In the if block is executed if the parameter which is passed to the function z is an integer, then this will be executed. But if this z happens to be a list, then this will be executed. This is the function, and I'm making two calls. Is it clear so far? Has everybody understood? Let me then only I'll move forward.
Yes. Yes, sir. This much is understood.
This much is understood. Okay. So now what I'm doing is I'm calling z with I'm calling f with two different types of data. The first call is when z is an integer. The second call is when z is a list. So I'm trying, with this example, I'm trying to explain to you the difference between call by value and call by reference. In the first type, when a is an integer, then a here continues to be 5. It gives a copy of 5 to z. This is something like, suppose you have been asked to write an essay and the teacher gives you half the essay and asks you to complete it. All right. So what you do, you give that essay to your friend. Right. So if you are giving a copy of the essay to your friend and you ask your friend to modify it, then the original with you remains intact. That means you have given a value to your friend, right? So therefore, whatever changes your friend is making in that piece of essay or whatever, that will be something different from your original essay. It will not get changed. However, if you decide you have a lot of faith in your friend, you think that he's a very good person and he will do a good job. So you give the original to your friend and you ask him to modify. So that is called call by reference. So let me explain. If you are giving the copy of your variable to the function, it is called call by value. If you are giving the original item to or data to your function, it is called call by reference. In Python, whether it will be a call by value or call by reference depends upon the type of data. If it is a primitive data type like integers, floats, bool, complex. If these kinds of data are passed, they are always passed by value. That means the original thing does not get modified. However, if the data passed is of a complex data type, or data structures like lists, sets, dictionaries, and other things, then it is passed by reference. So I'll just explain. Now let me just run this function and explain to you what is happening. So let us see the just one second. Now just see, I have put a equal to 5 and then I've called f with a, right? And now after the function call, if I ask the interpreter to print the value of a, it continues to be 5. That is why when I this thing, wait, And now if I now let me show the second call. The second call is when C is a list and I call FC. So this part of this thing is executing. C contains of 3 items, 5, 4, and 3. Inside the function, I have appended a 1 to the Z. Now this C has gone into Z. And 1 has been appended, and now after the function call, when I print C, it gives me a, so now it has added a 1 to, that means the function has permanently changed the object. So therefore, if I may put it like this, if I can take a blank, some blank paper, let me see if I can open a Word. Just one sec, I'm opening a blank page. So okay, oh no, not this one. Anyway, no, not this one. Just one sec. So what is happening is that if there's a function, say f, and it is defined def f colon something something something. Now, if I call this function, say I call f with number 5, then this or with something. Now this 5 will go here, but the original will not be modified. But if I call it, suppose with the list L, or say let's call it L1 equal to 2, 3, 4, and I pass this list to the function, and the function has some method whereby it is adding something to this function. In my case, I added a 1 to it inside the function. So the modification inside the function will remain even when the function call is over. That means the object is permanently modified. Is it clear? I mean, this will be clear. This might be slightly difficult to explain, but once you do it, I'm sure it will be understood. Is it clear? Let me, otherwise I'll try to give 1 or 2 more examples.
Sir, I had one question.
Yeah.
Sir, is call by reference only applicable to mutable data types?
Call by
Reference.
See, I've not covered the concept of mutable and immutable.
Okay, sir.
Not necessarily. It is not about the mutability. I think it's about the whether it's a primary, whether it's a primitive data type or a complex data type. Now, for example, a list is mutable, whereas a tuple is immutable, if I remember correctly. So it is not only about mutability, but it is also about the type of data. The primitive data types are always passed by value. The complex data, let me write a small script. Let me just, it'll take a second, let me write it. Maybe that will make this thing. Let's do a def. Let's call it F5 X. Right, okay. And let's say X is equal to X plus 1 print X, right? Let's call this function. Let's write Y is equal to 6, right? And let us say F5 Y. And then let us do print Y. So just let us run this function. Now, I just want to show you this is a case where the value has been passed by value, where the variable has been passed by value. That means y is a 6. When I call fy with a 6, it goes here and it becomes a 7 here, and that is why you get a 7 over here. But when I come out of the function, the y continues to remain a 6. It is not changed. This is an example of how the variable has been passed by value. The original y continues to be 6. No doubt inside the function f5, it became a 6, it became a 7, but that did not modify the original y. It continued to be a 6. Okay, so now let us take a different case. Let us take a case of y equal to maybe 1, 2, 3, right? Can we do plus in list? I think we can. Let us try. No, we can't. We cannot add, we cannot write. We have to write append. I think that is what we have to do. Let me see. Yeah, append. So the way to add to a list is to use append. So let us write x dot append. Let us write 4. I think that's correct. Append 4. Let me just confirm. Append, yeah. So let me now run this. So what has happened now? Let me just show you this. This is a case of passing by reference. So I passed a y to this function. Here x has become this 1, 2, 3. I appended a 4 to the x. Note, I did not append the 4 to the y. I appended the 4 to the x inside the function. So x is a, let me just, to make it things understand, let me write print. Let me make it more readable. Yeah. So now let me do it. Okay. So what is happening? The y is a list consisting of 3 items. I called this function f5 with a y. So the y was passed to the x by reference. And x was added, a 4 has been added to the list. And when I print this x over here, you can clearly see that 1, 2, 3 ke saath mein 4 has also been added, right? Now I have come out of the function. Now when I asked you to print the y, again I'm getting a 1, 2, 3 and a 4. That means y has also been permanently altered by this function call. This is a call by reference. Does it make sense? I want to, because this is important concept, so I need to.
Sir, I have a question here.
Yeah.
So when we did it with the integers, when you printed 6 and x is equal to x plus 1,
Yeah.
and we did y is equal to 6. When we call it y, when we asked to print y, it was giving us the value of 6 only.
Right.
But
Right.
here it is changed permanently. Why so,
Yes.
sir?
Because it's a call by reference. Because I'll tell you, so this is the way the Python interpreter works. So when I'm passing an integer, suppose I have an integer x, and I pass it to a function f a. Then this, suppose it is 5. Then what is happening? The interpreter does, it takes the 5, it gives it to a. Right? The x continues to remain 5. But suppose I had x equal to some list 1, 2, 3. So here what is happening? Here when I'm calling, suppose I call fx now. So what is happening is a is getting the address of this object.
Okay.
It is getting the address of this object. It is not creating another copy of the object. It is not like that now a is another list. A is a different list which is in different part of the memory. It is the same list in the same part of the memory which has been passed to A. So when I do anything to that list inside that function, and when I come out of that function, that X also gets modified. Rather, the X gets modified because A and X are pointing to the same object. Is that clear?
Okay, sir.
Yeah. So I think that the concept of passing by,
Sir?
if you have, yeah, please.
Sir, I have a question.
Yeah.
Sir, is there a way to pass integer by call by reference? Is there a way to do that?
Passing an integer? No, I don't think so. I have never come across the scenario. You will have to create the integer inside. You'll have to put the integer in a list. Then you can modify.
Oh, okay, sir.
You can maybe do something like this. You can suppose you want an integer, maybe you can do x equal to 5. And then you can pass it to the function, and then you can convert it into an integer. There are ways of doing it. But integer will always be passed by value. Integers, floats, bools, complex, these are always passed by values. But you see, different programming languages deal with these things differently. So if you're coming from a background of a different programming language, maybe it works differently over there, but this is the way it works in Python. I do know a little bit of C++. I did many years back, but by and large, I don't know how C++ works. So I will not really be able to compare the languages like some of the other experts. I only know Python. I hope that answers your question, right?
Yes, sir.
Yeah. Okay. So this much if we have understood, can we move to the next concept, right? And that is called default arguments, position arguments, and keyword arguments. Let me just default arguments, position arguments, and keyword argument. Let me see if I have any example of that. Oh no, maybe I'll open this. Yeah. Okay. Is my screen visible, or should I make it a bit bigger maybe? Okay. Now just have a look at this definition of a function called f. It has got two variables, a and b. But I have put a equal to capital A within. So this a is a variable, and this a is a string. Similarly, this b is a variable, and this b within quotes is a string. So what is happening over here? Let me just make it again so that the thing gets wiped out. So I have two variables, a and b. And I have given them value capital A and capital B, which are both strings. And this function is from here to here. It has only two lines. First is the definition, and second is a print statement. That's all. Now I have called this function in three different ways. This is way number 1. This is way number 2. This is way number 3. Let me repeat this. So I have defined a function. These first two lines are defining the function, and these three statements 1, 2, and 3. Each of them are calling this function with different arguments. So let us see what happens. In the first case, I'm calling 1, 2. In the second case, I'm calling with 3. In the third case, I'm calling with nothing, with no arguments. So how this works is that this A has a default value of capital A, and the B has a default value of capital B. But when in the first call, I have called them with 1 and 2. So these default values will be ignored, and A will become 1 and B will become 2. Therefore, we'll get an output of 1 and 2. So let me just again write it. Here, I'm calling with two arguments 1 and 2, 1 and 2. So A becomes 1 and B becomes 2. Not this B, sorry, this B becomes 2. And when I call this function, I get 1 and 2. In the second call, I am calling with a single variable 3. Since there are 2 parameters inside the function, the 3 goes to A. And since there is nothing for B, the B takes a default value of capital B. So we get a 3 and a B. In the third case, I am not giving any arguments. And when this print happens, the A is for A, capital A is printed. And for B, capital B is printed. So this is how default values work. Now you tell me, have you understood this concept or do I need to explain it again? So basically, if I don't give anything, like here, then A and B will be printed for A and B. But if I give both, then this A will be ignored, this B will be ignored, and this 1 will be printed for A and the 2 will be printed for B. But if I give one of the two and I don't give the other, then this 1 will go to the first one and the second one will be the default value. So this is called giving the default values to functions. Now you might ask, why do we need to do these things? In fact, if you go into libraries, like for example, if you go into the machine learning languages or libraries, you will find that there are functions which are having 25, 30, 40, 50 variables, right? But you may require, but most people will be needing the values of only the first 2 or 3. The rest can be default. But if you do not provide the default values, then the programmer will have to write the values for each one of those 50 variables. Therefore, to make the library easy to use, and most of them are default values. So to make the programmer or to make the library easy to use, most of the Python functions inside libraries provide default values for many of their variables. For example, I can't give you an example right now, but suppose you had a library which suppose say graph, which had a function called plot. So plotting ke liye, suppose you need to plot on X and Y axis. So plot may have X, may have Y, or plot may have X, comma Y. Then, but somebody wants to plot the graph with boxes. Somebody wants to plot with dots. Somebody wants to plot with this thing. So you might have you might say a point equal to dot. So let me just explain this again. Suppose you have a library called graph with a method called plot. And the plot has 3 items. The function plot has 3 called X, comma Y, comma point equal to circle. Now, if you give the value of X and Y, it will plot the X and Y in the form of a circle. But suppose you wanted to plot that point in the form of a square, then you could write plot. Suppose you want to plot 3, 4, 3, 4, square. Or you could have written plot 3, 4. So if you use this function, then the plot will be plotted with a circle. But if you use this function, then the plot will be plotted with a square. This is how Python libraries work. They will provide default values for things like type of plot point, color of the background, size of so many things. But those are the default values normally work. Most people will be happy to have a plot with a circle. but there might be a few people who want a square. So for them, there is a point variable which has the option of having a circle or a square. So if you want the plot to be plotted with a square, then you override, the word is override, the default value of circle by using the value of square. But if you're happy to use the default values, you simply plot with 3 and 4 and you're good. Is this clear? Or does it make sense? Let me stop here for a second. Somebody would like to answer? Or is it becoming heavy? Yeah? No
Yes,
one?
sir, understood.
Yes, sir.
Understood. Okay. Okay. So, but default values cannot be used indiscriminately. There are certain rules for default values. First, the default value assigned to a parameter should be a constant. It should not be a variable. It can be a string. It can be a list. It cannot be another variable. Only those parameters which are at the end of the list can be given default values. This is very, very important. I'll explain. When you provide default values, you must start from the rightmost parameter. You cannot have a scenario where you provide some parameters but don't provide default values to a parameter which is the right of this parameter. I'll explain. So the list of parameters, definition starting from left must have the first only those parameters without values and then with those with values. I'll just explain to you this concept. This will become clear. Just so okay. Here I have defined 5 functions: F1, F2, F3, F4, and F5. In F1, all the 3 variables have a default value, fine. In F2, the rightmost variable C has a default value, fine. In F3, the 2 variables starting from the right side, that is C and the B, have a default value, okay. But in F4, the first variable has a default value and the second and the third don't have. This is not allowed. So if you want to create this kind of a scenario, then you should write def F4, right? And you should write B, comma C and write A towards the end. So it should become F4, B, comma C, comma A equal to 1. Meaning thereby that you cannot have a variable without a default value to the right of the variable with a default value. Similarly over here, B2 has a default value, but C doesn't have a default value. You cannot have this kind of a scenario. Does it make sense? Anybody?
Yes.
So why is it so?
Because if you allow this to happen, now let us I'll tell you why this is so. Now suppose you allow this, right? Or let us do it with an example. Let us insert a cell above. All right, def. Let's call it fx. Print something. Let's print I. Now, if I was to call this function, now you see, I can call this function as, technically if this function was correct, I should be able to call it fx. I could call it 2, 3, 4. If I was to call like this, then if I was to call like this, then the 2 would go to the
A,
the 3 will go to the B,
B,
and the 4 will go to the C.
C.
right?
Yes, sir.
Okay. Now, but suppose I call it like this. Now what should happen? Tell me.
3 to A, 4 to B.
A to
3 to A,
and 4 to B.
4 to B.
Then will be an error because there is no C. And if you want to call this function, there must be 3 parameters.
So like in previous
But suppose this will throw an error. I'll just show you. If you try to run this, it will throw an error. See the error is very informative. Non-default arguments follow default arguments. So these are the non-default arguments. Sorry, this is the non-default argument. These are default. So non-default arguments cannot follow default arguments. But I suppose I was to remove this C from here, and I was to put this C over here. Should it run now?
Yes, sir.
Huh? What will be the value of C?
C would be 3.
C would be 3. And what will be the value of A?
4.
Right. So let us see. C is C, then A. Let us see. So we are getting a C. That means now we are able to call that. Just let me expand this. Now we are able to call this function with 2 arguments, because the number of arguments should be either equal to the number of arguments without default values or more than that.
Okay.
Right? So now the 3 has gone to the C and 4 has gone to the. Now suppose I try to call it like this. Will it work? Like this?
Yes.
Will it work?
Yes, sir.
No. It will not work.
No, it won't. C
It
is
won't,
there.
it won't. So वो
Because-
अपना 5, 6 ही आ जाएगा
Let
वो.
us run it. Now just see the error. Saying fx missing 1 required positional argument C. Right? But suppose I write C equal to 10. Will it
Okay.
run now?
Okay. Then it will run.
Now it will run. So now it is good.
Okay.
Now C is 10 and A is 10.
Mm-hmm.
So this is the thing. You cannot have a default argument to the left of a non-default argument. So you cannot, if you write like this, if you remove this, this is error.
Error.
Yes. Right? If you do this, that's fine. Right? Have I
Yes, sir.
explained?
Yes,
the,
sir. Yes,
the
sir.
concept of default arguments?
Yes, sir.
Okay. Anybody? I think only few people are probably involved in the question answer. So let me just try to take the general class as a whole. Let us hear from someone who has not spoken so far. Anyone? Otherwise, we'll move ahead. Okay. So I presume that this is clear.
You can go ahead, sir.
Okay. So this is another case. Let us run this program. Let me comment this out, otherwise it'll throw an error. So let us. So again, this is the function definition. And there are 1, 2, and 3 function calls. The first function call is with the ant and a bee. No problem. The ant will go into the A, the B will go into the B, the C will remain a cat, the D will remain a dog. No problem. Second case, the capital A will go into A, the capital B will go into B, the capital C will go into C, and the D will continue to be a dog. However, when I say, now let me Now let me do it with this F1. Now what does it show? So I'm
We
basically
have to provide A and B.
this error is coming from this line of code. Because there are two parameters in the function which do not have a default value. And I'm calling the function with only one argument. So the compiler doesn't know what to do with the B. The compiler is able to move the 1 to the A, not a problem. The compiler can continue to keep C as cat. The compiler can continue to keep D as dog, but the compiler doesn't know what to do with the B. There's nothing for B. So the compiler throws an error. Therefore, when you call with an AND and a B, the compiler is happy because the AND goes to A and the B goes to B, and the C and the D are also fine. However, if you try to call this function with only one argument, the compiler complains and it throws an error. Let us comment this out. And let us comment this now again. Sorry. Now again, let us done this. So what is saying? Now see. Now it is complaining even more. Earlier it was saying only one missing argument. Now it is saying two missing position arguments, A and B. So what the compiler is saying कि भाई A और B का क्या करना? I am not able to understand what to do with A and the B. So therefore the compiler is throwing an error. Should we stop here? Because I think we have covered a bit. Tell me, would the class like to continue or should I stop here? Anyone?
I think it's okay.
Yeah, I
It's
think, because
heavy for today.
yeah, it is quite a lot. We have covered scopes, we have covered position arguments. Yes, we have covered quite a bit. We have covered so
Calling
many things we
function.
have covered. If you have learned this much, if you have followed what I have told you so far, then we are good on our way to learning Python, and we should be able to finish functions in the next class. Functions are a bit complicated because I have not covered some of the other more complicated aspects of functions. So once you understand that, then we can move straight to classes. And once you know classes, then you're on your own. You can really start doing hardcore programming in Python. So I think I will stop over here. Is Balaji online? Mr. Balaji? Or Madam is there? So, okay. So we will stop over here. Thank you so much. And you can keep on looking on the GitHub page of my book. I've done a lot of effort in creating PPTs and chapters and this thing, and I'm sure you'll find it very, very useful. Okay, good night to all of you. I'll stop here.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thanks,
Good
sir.
night.
Thank you, sir.
Thank you, sir.
Thank you, sir.